During this video, we're going to be talking about electrical and electronic components. The first component that we're going to talk about is the cell, and its main function is to supply electrical energy to any electronic device. Next, we have a battery. A battery is formed from two or more cells, and its function is the same, to provide electrical energy to any electronic device. Now, the filament bulb does not contain any positive or negative leads. Therefore, it doesn't matter if you were to swap those two wires of the bulb holder, as the filament bulb will still give an output. Next, we have a toggle switch. Now, this toggle switch is going to function as an SPST switch. This SPST, or single pole single throw switch, will only allow current to flow in a circuit only when it is on the closed or on position. Next, we have a push-to-make switch. This input device allows current to flow only when the button is pressed. When the button is released, the switch will go back into its normally off state. Now we're going to be talking about the LED. LED stands for light emitting diode. This output component converts electrical energy to light. However, this one has a polarity in it. The longer lead is called the anode, which is the positive. The shorter lead is called the cathode, which is the negative. When connecting an LED, the anode has to be connected to where the conventional current is going to flow through first. The cathode has to be connected to where conventional current is going to flow out from. Now, if we were to connect the LED the other way around, meaning cathode to the positive side and the anode to the negative side, the LED will not conduct any electricity, therefore it will not turn on. This happens as the LED is made up of a semiconductor material. Now let's talk about the resistor. And the primary function of a resistor is to restrict the current flow of a circuit. The color bands of a resistor show us the value of a resistor's resistance. In this case, this resistor that we have here is a 330 ohm resistor. And in this circuit here, I'm going to use the resistor to protect my LED. This is because I am using a 9-volt battery to power up a 3-volt LED. Therefore, my resistor is going to take the excess 6 volts from the battery from the LED. If I were to connect the LED directly to the 9-volt battery, due to an overload of current and voltage, the LED would either burn or blow up. Then we have the buzzer. A buzzer is an actuator, which is an output device that converts electrical energy to sound. Here we can tell that this buzzer also has a polarity due to the red and black wires. So, when connecting a buzzer, the red wire, which is the positive side, has to be connected to the positive side of your power source. The black wire, which is the negative side of our buzzer, has to be connected to the negative side of your power source. So electricity will move from the battery to the resistor to our buzzer and then to the negative wire, then back to the negative side of your battery. Finally, we have a DC motor. A DC motor is another actuator which converts electrical energy to mechanical rotary movement. To see which direction our motor is going, I'm going to take a piece of tape and apply it to the motor shaft. Now let's connect the motor directly to our 9-volt battery. And notice that by connecting the motor this way, the motor is rotating in a clockwise rotation. And notice that if I were to swap those two wires, our motor will rotate in anti-clockwise. And that was our final component that we had to talk about.